In equilibrium, the second part is ionic equilibrium. Ionic equilibrium. These two are very important one. Then first PUC is basic for the second PUC. If you perfect with that of the chemical equilibrium, then in second PUC it is basic for chemical kinetics chapter. Chemical kinetic chapter. If you thoroughly study this ionic equilibrium chapter, chapter, in the second PUC you can have the knowledge about electrochemistry chapter. Ionic equilibrium is the foundation for this electrochemistry chapter. Chemical equilibrium is the foundation for the chemical kinetics chapter. This is second PUC portion and this is second PUC portion. Okay. What is ionic equilibrium? You know that the electrolytes means they are nothing but acids or bases or salt solutions. And these, when they dissolve in water or in aqueous medium or in a solvent medium, they have equilibrium with that of the undissociated molecules. Therefore, the branch of this chemistry that deals with the equilibrium between the charged particles or the ions with that of the undissociated molecules, that is called ionic equilibrium. Here you come across the very important concepts. What are electrolytes and non-electrolytes? Electrolytes and non-electrolytes. Electrolytes and non-electrolytes. Electrolytes and non-electrolytes. What do you mean by this electrolytes? Electrolytes. A chemical substance which undergoes ionization in aqueous medium. Then it releases the charged particles. They are called electrolytes. Electrolytes are the chemical substances which undergoes ionization reaction in aqueous medium or the solvent medium. If suppose they undergoes ionization completely, they are considered as a strong electrolyte, and if suppose they undergoes ionization partially, they are called as a weak electrolytes. Whereas in case of the non-electrolytes, where that does not undergoes ionization, when they are put it in solvent or aqueous medium or water medium, whatever it may be, they are considered as a non-electrolytic solutions. Now, electrolytic solutions and non-electrolytic solutions. Electrolytic solutions are further classified into strong electrolytes and weak electrolytes. Strong electrolytes and weak electrolytes. Now come to the definition of the important factors, that is strong electrolytes and weak electrolytes. A compound which conducts electricity in molten state and in aqueous solution is called strong electrolyte. Electrolyte, a chemical substance. Electrolyte is a chemical substance, a compound which conducts electricity. A compound which conducts electricity in molten state. Or in aqueous solution. Is called an electrolyte. A compound which conducts electricity in molten state, or in aqueous solution is called an electrolyte. What do you mean by molten state and in aqueous solution? Molten state means when the solid compound on heating, that is called as a molten state. Molten state and aqueous medium. What is the difference between these two? Aqueous medium means whenever the electrolytes are put it in water, that is nothing but water plus electrolyte. Water plus electrolyte. That homogeneous solution is called as a aqueous medium of the electrolyte. Whereas a solid on heating, then it gives solid on heating, then it gives the fused mass. That mass is called as a molten mass of the electrolyte. Solid alone on heating, not you are putting any water or any suitable solvent. For example, you take sodium chloride. On heating the sodium chloride in one container, then we got the molten mass of the sodium chloride. That is called as the molten state of the electrolyte. That is the fused mass. Because solid substances, for example solid sodium chloride or solid copper sulfate, whether they are the good conducting materials? No, they are not good conducting metals, because in solid state the ions are rigidly packed and there is no free space that is available for the movement of the charged particles. That is why all chemical substances in solid state, they are considered as bad electrolytes. But whenever the fused mass is there, in aqueous solution is there, then that is sufficient space that is available for the movement of the charged particles, and hence they are good conductors in fused state or in aqueous solution. Don't feel that sodium chloride is a good electrical conductor. No, sodium chloride solid is a bad conductor because the non-availability of the space to move the ions. Okay. But in case of the metals, it is true. Metals in solid state, they conduct electricity, but metallic compounds in fused state and electrolytic medium, ionics, that is aqueous medium, they conduct electricity. Therefore, a compound which conducts electricity in molten state or in aqueous solution is called an electrolyte. All acids and bases, all acids like that of the hydrochloric acid or sulfuric acid or nitric acid or acetic acid or even formic acid, HCOOH, formic acid, or similar type of the carboxylic acids. They are good examples for acids, that is electrolytes. And even bases like that of your sodium hydroxide, bases like sodium hydroxide or potassium hydroxide, NaOH, or potassium hydroxide or ammonium hydroxide. Ammonium that refers to ammonium hydroxide and amines, organic molecules, amines. These are bases, they are electrolytes. And salt solutions of sodium chloride or potassium chloride or copper sulfate or zinc sulfate, or barium chloride and ammonium chloride. Now these are the salts which are derived from that of the acids and bases. They are good electrolytes. Therefore acids, bases and salts in aqueous medium, they are good electrolytes. This is about the definition of the electrolytes and the non-electrolytes. Now what about non-electrolyte? Non-electrolyte is a substance which does not conduct electricity in the molten state or in aqueous solution. Non-electrolytes. What do you mean by non-electrolytes? Non-electrolyte is a substance which does not conduct electricity either in molten state or in the aqueous medium. Non-electrolytes. What do you mean by non-electrolytes? Non-electrolyte is a compound a compound which does not conduct electricity, in molten state, it does not conduct electricity in molten state or in aqueous medium. Molten state or in aqueous medium. Which does not conduct electricity either in molten state or in aqueous medium. You know that what you mean by aqueous medium? That is in water medium. You know what is molten state? That is a fused state. When solid substances upon heating, then they gives rise to the molten solution. Here, examples are usually covalent bond compounds. Covalent bond compounds. Whereas the good examples are urea, glucose, benzene, urea and glucose and benzene, usually all organic molecules which are formed by means of covalent bond, like ethyl alcohol, etc. Usually organic molecules which are formed by means of the covalent bond. Are considered as non-electrolytes. What are the differences between electrolytes and non-electrolytes? Differences between electrolytes and non-electrolytes. Mention the differences between electrolytes and non-electrolytes. Electrolytes and non-electrolytes. When there is a difference, make two columns in your notebook. In first columns you have to mention electrolyte. In second column you have to mention non-electrolyte. First column you have to mention electrolyte. Second column you have to mention non-electrolyte. Non-electrolyte. First difference that should be the definition. Electrolyte is a chemical substance which undergoes ionization in molten state. Electrolyte is a substance or chemical substance. Electrolyte is a chemical substance which undergoes ionization in either in molten state. Ionization either in molten state or in solution phase. Either in molten state or in aqueous medium. Either in molten state or in aqueous medium. Non-electrolyte that does not conduct electricity. non-electrolyte does not conduct or does not undergoes ionization, does not undergoes ionization, does not undergoes ionization, does not undergoes ionization either in molten state, either in molten state or in aqueous medium, either in molten state or in aqueous medium, either in molten state or in aqueous medium, either in molten state or in aqueous medium. Second one, there are ionic bond compounds. They are ionic bond compounds. They are ionic bond compounds. Ionic bond or electrovalent bond. Electrovalent bond. Ionic bond, electrovalent bond compounds. They are ionic bond or electrovalent bond compounds. And these are covalent bond compounds. They are covalent bond compounds. They are covalent bond compounds. They are covalent bond compounds. The bond is very important. You know the difference between the ionic bond and the covalent bond. In ionic bond, the complete transfer of the electrons that will occur between more electropositive element to the more electronegative element, that sort of the inorganic force of attraction between the positively charged and negatively charged ion is called electrovalent bond or ionic bond. Usually they are solids at lab temperature and they are completely soluble in water. But there are covalent bond compounds. In covalent bond compounds, usually the sharing of the electrons that occurs between the two atoms, whereas each atom that contributes one electron for the bond formation, they exist either in gaseous state or liquid state with low melting point, or liquid state with low boiling point, and solid state with low melting point. That are the features of the covalent bond compounds. Okay. Usually these are inorganic compounds, these are organic compounds. Usually they are inorganic compounds and these are organic compounds. Okay. They contain free ions in the solution. They contain free ions in the solution. They contain free ions. They contain free ions in the solution. They contain free ions in the solution. Free ions in the solution or in molten state. Or in molten state. Free ions in the solution or in molten state. Or in molten state. What about this electrovalent bond compounds? They contain free molecules. They contain free molecules. They contain free molecules in the molten state or in solution phase. They contain free molecules. They contain free molecules. They contain free molecules either in molten state. This is molecules either in molten state or in solution phase. Molten state or in solution phase. Solution phase means aqueous medium. Aqueous medium. Solution phase or in aqueous medium. This is aqueous medium. You can write, no confusion. Aqueous medium. Aqueous medium. Aqueous medium. Aqueous medium. Usually they are acids. They undergoes decomposition. They decomposes, discharging the ions. They undergoes decomposition. They does not undergoes decomposition. They undergoes decomposition. They undergoes decomposition. Thermal decomposition. undergoes decomposition, or usually there are good examples for this is acids and bases and salts. Acids and bases and salts. All acids, bases, salts. All acids and bases and salts. Molecules of the organic compounds. Molecules of the organic compounds. These are molecules of the organic compounds. 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 Already I mentioned the organic compounds like urea or glucose or benzene or alcohol, ethanol. These are the molecular reactions. Actually, these are ionic reactions. Molecular reactions are ionic reactions. These are the important differences between the electrolytes and non-electrolytes. Important differences between the electrolytes and non-electrolytes. Electrolytes are further classified into strong electrolytes and weak electrolytes. Electrolytes are further classified into strong electrolytes and weak electrolytes. Strong electrolytes are those which undergoes complete ionization reaction in aqueous medium, and weak electrolytes are those which undergoes partial ionization reaction in aqueous medium. Electrolytes are classified. Electrolytes are classified in two classes. They are strong electrolytes. Strong electrolytes and electrolytes are classified into strong electrolytes and weak electrolytes. What is by strong electrolytes? Electrolyte which undergoes complete ionization in aqueous medium. Electrolyte undergoes complete ionization reaction. Undergoes complete ionization in complete ionization in aqueous medium. Complete ionization in aqueous medium. Electrolyte which undergoes complete ionization in aqueous medium. They are called as a strong electrolytes. The strong electrolytes. Example for the strong electrolyte: strong acids. Strong acids. Good examples like HCl and HNO3 or H2SO4. These are strong electrolytes or strong acids. And strong bases. Strong bases. Strong bases means alkalis. Strong bases means alkalis. Like that of sodium hydroxide and potassium hydroxide. Strong bases. Strong bases. And salts derived from strong acids and strong bases. Salts derived from strong acids and strong bases. Strong acids and strong bases. Salts derived from strong acids and strong bases. Like that of the KCl and NaCl. Like that of NaCl or KCl or sodium sulfate or potassium sulfate, sodium sulfate and potassium sulfate. These are good examples. These are good examples. Okay, this is for strong electrolytes. What are the weak electrolytes? Which undergoes partial ionization reaction in aqueous medium. Which undergoes partial ionization reaction in aqueous medium, and hence the degree of dissociation is very weak. Degree of dissociation is very weak. Degree of dissociation is very weak. Weak electrolytes. Weak electrolytes. Weak electrolytes. Electrolytes undergoes partial ionization reaction. Electrolytes undergoes partial ionization, electrolytes undergoes partial ionization in aqueous medium, partial ionization in aqueous medium, partial ionization in aqueous medium, partial ionization aqueous medium with lesser degree of dissociation, with lesser degree of dissociation, with lesser degree of dissociation are called weak electrolytes. Lesser degree of dissociation are called weak electrolytes. Usually they are weak acids, like that of the organic acids, like acetic acid or formic acid or oxalic acids, or citric acid and so on. And weak bases, like that of ammonium hydroxide, weak bases like ammonium hydroxide and all class of amines, ammonium hydroxide and amines, and salts of weak acids and weak bases, salts of weak acids and weak bases, salts of weak acids and weak bases, weak acids and weak bases, like that of your ammonium acetate, salts of weak acids and weak bases, like that of ammonium acetate, ammonium formate. These are examples for weak electrolytes. Now we have strong electrolytes, weak electrolytes and non-electrolytes. Strong electrolytes, weak electrolytes and non-electrolytes. These are the important classifications of this chapter. Now you should have the awareness about the strong electrolytes. Now what about partial ionization or lesser degree of dissociation? A fraction of the electrolyte that dissociates out of 1 mole, that is called degree of dissociation. Now we have knowledge about electrolyte, strong electrolyte, weak electrolyte, strong electrolyte, weak electrolyte and non-electrolyte. Strong electrolyte, weak electrolyte and non-electrolyte. Now we have mentioned a very important word, that is degree of dissociation. What about degree of dissociation? This is only for weak electrolytes. What about degree of dissociation? That I mentioned one word in case of the weak electrolyte point. That is the degree of dissociation. That is nothing but the fraction of the electrolyte that ionizes or dissociates out of 1 mole is called degree of ionization or degree of dissociation. Because the weak electrolytes, the dissociation rate is very less. Suppose if you put 1 mole of the electrolyte, then only 1% or 2% of the electrolyte that undergoes ionization. That fraction is called as a degree of dissociation, whose value is very negligible value, either 5% or 10%, that's all. If you put a formic acid or acetic acid in water, only 5% or 10% of the acetic acid molecules or formic acid molecules that undergoes dissociation. Remaining is in equilibrium with that of the undissociated molecule. That is why we talk about the ionic equilibrium. Therefore, in ionic equilibrium, we are dealing with that of the charged particle and equilibrium with that of the undissociated molecules. For example, in case of the strong electrolytes, no problem. The degree of dissociation is 100%. There is the more number of all molecules that undergoes ionization. But in case of the weak electrolytes, where the degree of dissociation is less, that's the important differences between the strong electrolytes and weak electrolytes. In case of the strong electrolytes, the degree of dissociation is maximum. In case of the weak electrolytes, the degree of dissociation is fraction. Only few percent of the molecules that undergoes dissociation. Only few percent of the molecules that undergoes dissociation. Is it clear? Okay. Thank you. Next class we will discuss about the acids, bases and salts. Thank you.